Hello everyone, my name is Jared, and today I will show you how to do this Physics 161 problem. This is number 2 from midterm 1 of fall 2006. So a block of mass 0.3 kilograms is on an inclined plane that makes an angle of 60 degrees above the horizontal. The coefficients of friction between the block and the plane are mu of s is equal to 0.6 and mu of k is equal to 0.2. A horizontal force is applied to the block to keep it from sliding down the plane. So part A asks to draw a free body diagram for the block, showing all forces acting on the block. Clearly indicates the physical origin of each of the forces. Part B asks, what is the minimum horizontal force that must be applied to the block to keep it from moving? So the solution to this is, first we have to write our knowns. We know that the mass is 0.3 kilograms, theta is 60 degrees, and our two coefficients of frictions for static it's 0.6 and for kinetic it's 0.2. And we could assume that this is on Earth since nothing else is mentioned. So G will be equal to 9.81 meters per second squared. And what we want to find is the FBD and the minimum horizontal force. So the FBD will have our block sitting on the plane or the incline at the theta degrees. So first is the obvious choice of gravity of the weight of the block. That will be at the center. Then you can have the normal force pushing from the center of the block from the inclined plane itself. So that will be situated over here. Friction will be acting on the block, and that will be at the topmost point of where the block will meet the incline, and it will go along the surface of the incline. And then a horizontal force is applied at this corner. So it can be labeled simply F as the applied force. Now to find the minimum horizontal force, first we have to see that it's in equilibrium, since if it's the minimum force, it shouldn't be able to move. So F of x is equal to 0. So that means the frictional force plus the horizontal component of the applied force minus the horizontal component of the weight force. And then for the sum of the y forces, it's going to be equal to 0 again. And it's the normal force minus the vertical component of the applied force minus the horizontal component of the gravitational force. So you can see that the axes are tilted for this FBD to make the things easier for this problem. And in order for the horizontal force to be minimized, that means that static friction is maximized. So we will be using the static friction coefficient, and we'll use the fun equation, F is equal to mu s of n. So we can replace the frictional force from the F of x equation over here to include the mu of s and n, and organize it so that could be n is equal to mg sine theta minus f cosine theta over mu s. And then we take this y summation forces and set it so that the normal force can be replaced with this expression we just solved for. Then we can reorganize the equation to start simplifying it and canceling out units till eventually we get f is equal to mg times the quantity of sine theta minus mu of s times the cosine of theta over cosine theta plus mu of s sine theta. And if we plug in the values we previously had known, we can get a minimum horizontal force of 1.63 newtons. Thank you.